All right, in today's lesson we're going to talk about the key features of a quadratic function. So a quadratic function is basically, it looks similar to what I've just written here in Desmos. Every quadratic has to have an x squared term as its highest exponent term. And so if you go to Desmos, you can easily type this in and it will create this parabola or U-shaped graph for you. So we're going to talk about some key features about this graph today. One thing to notice in Desmos, if you're using this at home, when you hit the gear, you have the option of going to the table. And when you do that, you can see what different values of x lead you to for the output of the function. Okay? And the other cool thing is you can change, like if you wanted to know what happens when the function is evaluated at x equals 3, you can type that in and it will tell you. And then if you wanted x equals 4, type that in and that will tell you as well. Plus it also shows it on the graph. So use Desmos to help you with the lesson practice that I'm giving you. It will be a great tool. We are going to go over to my document camera here, and again, this is the exact same function that I put into Desmos, and I use the Desmos table to fill out this table here. I just inputted the different x's and it gave me these different y output values. Okay. Something I want you to notice about the table is that here at -1, that input gives us an output of 12. That's not something I could graph on this grid, but at -1, it would be way up here at 12, and then when x is 0, it's at 5, and so on. You can see in the table and the graph that we started high, and then we started to decrease. We decrease all the way to -4, which you can see is our minimum. This is also known as the vertex. And then at the vertex, it changes directions and it starts to go back up. The cool thing about a quadratic is that it is symmetrical. So here's the vertex. Notice on either side of it are the same y values, both -3, and then on either side of that, 0. And then 5, and then if we had gone out to 7 in our table, there would be a 12 here. And that symmetrical pattern would continue as we go out. All right, so we're going to talk about some key features of quadratics today. The first thing is, in general, we want to know if the graph opens up or down. Now we can tell from the graph for sure that it's opening up. We can also tell from the table because we went all the way down to a minimum and then went back up. So we know that if we have a minimum, then that means our U-shape or our parabola is opening up like so. Okay? You can also tell that in the equation. If you look at this value right here, there's a 1 here. This is known as the A value. If your A value is 1, or if your A value is a positive, I should say, it will open up in a smile. If your A value is a negative number, it's going to open down in a frown. But it's very obvious from the table and the graph that this opens up. All right. A few other things that you need to be aware of is how to identify the y-intercept. This is fairly easy. You can see the y-axis is the vertical axis. And so it crosses the y-axis at 5. Okay, we can also see this in our table. That is our 0 term, 0, 5. Okay, so that is our y-intercept. The axis of symmetry is the fold line. It would be the line where you would fold the graph and it would fold onto itself. Okay, it's also the center line. It always goes through the vertex, which is our minimum point right here. And because this line is vertical, it has an x equals equation. Notice it goes through the x-axis at 3. So we would say the axis of symmetry is the vertical line at x equal to +3. Whoops. Okay. Then we want to look at the vertex. The vertex is, in this case, our minimum. If our graph had opened down, the vertex would be our maximum. And this point right here, we can see in our graph is at 3, -4. Okay, we can also see that in our table because that is where our graph changes from going down to then going up. So that is our minimum, otherwise known as our vertex. So I will put 3, -4 as that value. All right, a few more things that you might need to know to describe a quadratic is its decreasing domain, which is just the x values at which the graph is going down. Okay, so we can see that for x values of basically -infinity all the way to 3, where it hits its minimum, we are decreasing. Okay, so we would say that the decreasing domain is between x values -infinity and +3, okay, which is the x value right here where it hits its vertex. Then at that vertex it begins to increase, and so the increasing domain would start at an x value of 3 and would continue for the rest of the x values up to infinity. The range describes the y values that the graph hits. So here we're thinking in terms of the y-axis, which is our vertical axis. Okay, we can see that the lowest that it hits is right here at -4. And then it'll open up forever along the y. So this would be, the range would be -4 as the lowest y, and that would open up forever to positive infinity. Okay. The last thing that we want to talk about, which is a really important part of quadratics, are the zeros, otherwise known as the x-intercepts. Okay, these are really important because, as we've talked about before, and you'll hear again, these are considered important because they help us find the solutions to the quadratic. Okay, so the x-intercepts are where they cross the x-axis, which of course is right here, this horizontal axis, and so we can see that one of those x-intercepts is at 1. You can also see that in the table because that's where the function, the y value is 0, is at an x value of 1, so that would be one x-intercept, and the other one is at 5. And you can see that in the table as well, because that again is where the graph or the y value zeroes out, and so that is 5, 0. Okay, so these are the main features of a quadratic that you will need to be able to identify.